Section 3.4.27-T. The table shows the weekly income of 20 randomly selected full-time students. If the student did not work, a 0 was entered. So here's the table to the right. Check part A, we want to check the data for outliers. So in order for us to check for outliers, we're going to have to find the lower and upper fence. Before we do that, we need to find the quartiles. So we're going to open up the data in StatCrunch. And we see that our column here, we want to go to Stat, go to Summary Stats, and then select Columns. We're going to take a look at Variable 1. Okay, so what we want is quartile 1 and quartile 3. So there's quartile 1, quartile 3. And then we're going to then take this information and use that. Okay, so we can see here that quartile 1 is 129.5, so there's quartile 1, 129.5, and then quartile 3 is 377.5, and so there we have those two numbers. And then to find the interquartile range, we're going to take quartile 3, which is 377.5, and subtract 129.5 to get 248. So now, in order to find the lower fence, we're going to take quartile 1, which is 129.5, and subtract 1.5 and multiply that by the interquartile range to get negative 242.5. And then to get the upper fence, we're taking quartile 3, which is 377.5, plus 1.5 times the interquartile range, which is 248, and we're getting 749.5. So in order for us to check for outliers, what we need to do is we need to look at our data here, and we have to determine, is there anything that's outside the less than the lower fence and higher than the upper fence? Well, the lower fence gives us negative 242.5. So now that's on the list. And then the upper fence is 749.5. So if we take a look at our data, we have one number here that's 3,526 that's above 749.5. And are there any other numbers that are listed there that's outside of the lower and upper fence? Well, there's nothing else there. So we can notice that the data point is considered an outlier using this method if it is less than, again, the lower fence or greater than the upper fence. And we can notice here that the one observation, 3,526, that is outside this range. So therefore, there's only one outlier. So now we want to draw a histogram of the data. So we know that the lowest number that we have is 0. And if you notice here, we have 135, then we have 200, we have 300, then we have 500. So you can see here that we're going from these hundreds. So what we can do is, when we go to our data, we're going to create our histogram. We're going to select our column. We want our frequency. So we're going to start at 0 because that's the lowest amount on our data. Now, we can make the class width whatever we want. But since you can see that, there's hundreds that are difference between them, we can use 100 as the width. Now, again, this could be, you can change it the way you want, but you might get a clearer picture because of the data. That's what it has. So we're going to select Compute, and then we're going to take a look at the graph here. Okay, so when we look at this graph, okay, if we compare it to the result, okay, what you notice about this graph is what? Well, you can see that we have all this data here on the left-hand side, right? And then on the right side, we have that outlier. So it's showing with the outlier that's being labeled according to our 3,526. So it's important to be able to see that. Now, in part C, it's saying provide any explanation for any outliers. Well, there are many reasons for an outlier to occur. Some reasons are data entry errors, unusual but true observations, and also data collecting errors. So these are some things that can give you an explanation for any of the outliers.